3-2 and 3-3 with synthetic division is we've been looking for zeros. With this shortcut to long division method, you can always go back to long division, it works, but synthetic is just a shortcut that works whenever you're dividing by a linear factor. When x is to the first, that means with a coefficient of 1, even more specific, you can use this shortcut synthetic division. So again, you're looking for zeros, which are in the graphing world X-intercepts. The zeros where you get a remainder of 0 in synthetic division, you have found a k value that is an X-intercept of your polynomial functions. 3-1 through 3-4 is all polynomial functions. And remember that a polynomial function means all the exponents are whole numbers. So no radicals, which would be the fractional exponents, no negative exponents, just whole number exponents. Polynomial functions are guaranteed to be smooth and connected curves. Okay, no breaks in the graph yet. Now, Thursday's lesson, if you'll remember, is the one where we get all those funny little breaks in the graph, asymptotes, and there's a whole list of rules to try to figure out how to skeleton that graph in. So definitely make sure you don't miss Thursday's class for all that. But anyway, to graph a polynomial function, which is section 3.4, we put all of these steps together, and a complete graph should include the end behavior of the graph, the X-intercepts, which is what we've been focusing on in synthetic division, and the Y-intercept. The end behavior, that's a new rule. I haven't mentioned it to you yet. The end behavior goes by this list. If the polynomials, and you go by the degree, which is the biggest exponent, if the biggest exponent of your polynomial is even, it's an even degree polynomial, and its coefficient, the number in front of it, is positive, the two ends, the final ending of the graph, will be up and up. We've seen that in our parabola. A positive x to the second parabola is up and up. But it's true in general. If it's x to the fourth, x to the sixth, if the positive coefficient in front of it, up and up. If it's even degree and a negative number in front of it, it will be down and down, like a negative parabola. A negative number in front of an x squared makes a down, down. Okay, if it's odd degree, the ends split. If it's odd and it's positive, it goes from down to up. Left side down, right side up, which you can remember would be a positive slant on or a positive slope, because we read graphs from left to right. So this would be a positive direction for that. If it's an odd degree and it's a negative number, a negative coefficient, it starts up high and ends down low. There's a song in your note packet if you notice that. Calls that a high to high guy and a low to low, and has some little cute little phrases in that. A song that can go along with these rules. But anyway, that's what it's referring to. So that's not too hard to find. You can just use this list. Remember that. You've got number 1 checked off, the end behavior of your graph. The X-intercept's the hard part. The Y-intercept, let me go ahead and mention that. The Y-intercept is easy because it's just when x equals 0. Well, because it's a polynomial function, for example, this is number 12 example from your 3-4 homework. This polynomial function, to find its Y-intercept, if I plug in 0 for all these x's, 0 times 144, 0 squared times 20, all the zeros would just wipe out these terms and leave the last number. So when it's in this expanded form, the Y-intercept is just the number on the end. So it's no battle to find the Y-intercept. Those are the easy parts. And the end behavior, because it is positive, even, is up and up. So I can totally conquer those 2 steps just like that. But like I said, the X-intercept is our big battle. So I want to review how you find the X-intercept of any graph. The X-intercept is found by letting y equal 0. Here's why that's tough. Y is the same as f of x. So if we make that a 0, what we'll have is 0 equals this polynomial. And then I have to figure out how do you solve a 4th degree polynomial. And that's nothing that we've really had an experience with back in our old algebra. We've solved all types of 1st degree equation, linear equations, 2nd degree quadratic equations. We could totally solve those. If they didn't factor, we could use a quadratic formula. And even some 3rd degrees, if they were perfect cubes, we had a pattern for factoring those, but not all of those So in your homework on 3-2 and 3-3, what it did oftentimes is it would give you a hint and say, well, here's a given 0 to get you started, to start the synthetic division. But very rarely does this come up, but I just want to show you what we would do, some rules and strategies if you had no clues given and you were just hunting for your x-intercepts. All right? We can use this rule called the P over Q rule, and you had it, again, that was part of your 3-2 and 3-3 homework, hunting for zeros. The P over Q rule says if you take factors of your constant, P is the constant, the number at the end, no variable, the constant. Factors of the constant for 64 would be 1, 2, 4, 16, 8, 32, 64, and I may have missed some. Anything you notice? Anything else go into 64? I don't think 3 doesn't. I've got 4. 6 does not. I don't think. No. 7. So if you go through the factors, but that's what you're supposed to write on the top. Factors of the last number or the constant. I shouldn't say last number because they could have this all turned around and mixed up, but it's wherever the constant is. Factors of the constant. Divided by factors of the leading coefficient. Leading coefficient means find your biggest exponent, and that's called the leading coefficient, the number in front of that. So factors of 7 are just 1 and 7. And then we do just different combos of that. 1 over 1, 1 over 7, 2 over 1, 2 over 7. If you had to list all the possible combos, it's a pretty big list on this one. And you had, I know, a homework problem where you did that. I don't think the list was this long though. But you'd have positive and negative of all of these. Okay, because positive 1 goes into 1 and so does negative 1. So positive and negative of our list, 1 over 1, 1 over 7. 2 over 1, forgot to put 1, didn't I? 2 over 1, 2 over 7. 4 over 1, 4 over 7, 16. You know, the whole list, it would be a long list, right, if you had to list out all of those and then a plus and minus of all of those. Okay, and then you would start through the list. At least it's not every number in the world, so it's not infinite. It does have a finite number of things to try. So then you start through your list hunting for a 0. Every time you find a 0, you have taken this thing down 1 degree. It's a 4th degree polynomial, so as soon as we find one of its zeros, we'll factor it down to a 3rd degree, and so on. So it keeps breaking down. So I didn't want to start with 1/7, it's avoiding the fractions. So I just kind of randomly picked a number 4 and just trying to find something that works. So I did synthetic division with 4. 4 is on the list, 4 over 1. Use my coefficients like you do in synthetic division. I've got the 7, negative 45. Make sure that no place is skipped. You know, and I know in your quiz today that comes up whenever you write out your coefficients. Make sure you put a 0 for any skipped terms. All right, so I've used 4, my coefficients, and I got my 0. So kind of overlooked this second step because I was just getting ahead of you there. I got my 0 in synthetic division. I brought down my 7, multiplied to 28, added was negative 17, multiplied negative 68. I worked my way across. If you get a remainder of 0, that means this number is a 0, called a 0, or it's called the x-intercept, what it looks like when you graph. So we have found one of the x-intercepts at 4. Let me go ahead and get a sketch started here. What we know is the end behavior is up and up, and I don't know how far those need to be out, but just kind of to get a thought going there. The y-intercept is at 64, so wherever 64 is, I know that thing is going to cross the y-axis at positive 64. So now I've found one x-intercept at 4. And I could have up to 4 x-intercepts, so I'm hunting for those. Well, anyway, once I got 4 to work with a remainder of 0, now I can use these new numbers from the synthetic division row. You can kind of quit using the longer list and use this shorter list and start from there. So then we take that row and we start synthetic division again with a different number from the list, just any number you want to try. And I tried a few before I found this, you know, if you were watching, but I found negative 1 worked. So I went with negative 1, brought down the 7, multiply, add my way through, and I found another 0. Now the good news is once you get another 0, now I'm down to a quadratic. And if I get it down to x squared, then I can use the quadratic formula to solve the others. Or I can keep using this process. So you can see a little better. This list is now 7, negative 24, negative 16, remainder 0. So I've got 3 terms, remainder 0, which means it's a perfect factor, you know. Negative 1 is another x-intercept. Remember, each time you do synthetic division, you go down 1 degree. So it started 4th degree, then this was 3rd degree, so now this is an x squared. 7x squared minus 24x and minus 16 is a quadratic. If you want to do the synthetic division thing, you know, maybe try 8, 1/7 numbers from the list. I'm going to go a different direction and use the quadratic formula to find the other two zeros. So negative b plus or minus b squared minus 4ac, that's you, all over 2a. I could get an imaginary number, which would mean it doesn't dip through the axis if it doesn't come out real. All right, I need to get my calculator going, don't I? Okay, 24 squared. This will be plus because 2 negatives there. So I've got 4 times 7 times 16, 448 over 14. And you all know how this rolls in the quadratic formula. And you take the square root of what's under there. This comes out to be 32. So we get 2 nice rational answers, which means I could have kept on that synthetic division thing if there were rational zeros. It's 24 plus 32, which would be 56 over 14. Is that 4? Oh, at 4 again. And 24 minus 32, 24 minus 32, is that negative 8? Over 14, and then I want to reduce that, yeah, 4 sevenths. That was on that list too, because I had some 4s on the top and 7 on the bottom, so that, I would have avoided that one till last, probably, though, finding that 0. But anyway, I found all 4 of my solutions, or x-intercepts. And they're all real, so they'll all show up on the number line. Notice 4 worked twice. That's called a multiplicity, and you had some in your homework where that was happening too. If it says like you can use 4 and it's multiplicity 2, that means you use synthetic division with 4, then you can do it again with 4 on the next ramp. So you can use it twice. And that's going to be a significant rule in a minute too. And then this negative 4 sevenths, which would be around negative a half right there. So, I need to tell you some rules before I try to draw this thing in. So let's look at our list of rules for polynomial functions here. I'm going to need this number 5 rule, which goes along with the multiplicity rule. Multiplicities means repeated zeros, like we just saw happen here. 4 worked 2 different times. It was accounted for twice, so it's a multiplicity. Another example, if you had f of x factored in this form, that's a 0 at negative 2, repeated twice. So we call that a multiplicity 2, and that, of course, is x is 1, multiplicity 1. Well, when you get a multiplicity, here's how you graph it. The cut and bounce rule says if you have an even multiplicity, that your graph actually bounces off the x-axis at that number. So at our 4 solution, where it has a multiplicity 2 repeated there twice, we will bounce off the axis instead of cutting through. If it is an odd multiplicity, like a lot of them are just to the first power, an odd multiplicity, or to the 3rd power, it will cut through the x-axis. Okay, so now back over here. So here's what I know. Now, I don't know the exact turning points in here, but I know that it eventually goes up and up. So this thing is starting on the up side. It comes down at negative 1. It should cut through that. And then eventually, I didn't draw it very well. And it doesn't have to be perfect in this way. You just have to have your x-intercept, y-intercept, and the end behavior. The rest is kind of sketch it best you can. It goes down. It comes back up. It has to cut through negative 4 sevenths because it was just there once. Everything's there once except the 4s. It goes up, turns around at some point, maybe right at the 64, maybe above, and hits it down. And it comes back down, and then at 4, it's going to bounce instead of cutting through and then go back up. So I don't know. That's not a real lovely picture. But maybe you can check it on your graphing calculator and see what it really looks like.